Hey everyone, and welcome. It's great to be back to talk about, well, Starlink. Again.
Seems like these satellites are everywhere these days, even in the news.
You got that right. And today, we're diving into a brand new research paper. And get this, it was published just today, that's shining a light, so to speak, on what all these mega constellations, and Starlink in particular, are doing to, well, the night sky.
And we're not just talking about pretty pictures here. This paper gets into the nitty-gritty of radio astronomy.
Okay, so back up for a second, for folks who don't have their astrophysics degree handy.
Right. Essentially, radio astronomy is like listening to the universe, tuning into all those faint radio waves coming from black holes, galaxies, even the very, very early universe. We're talking about signals from billions of years ago.
Wow, okay, so way more than just, like, pretty pictures.
Exactly. But here's the thing. With thousands of these satellites up there beaming down data.
Which, don't get me wrong, is great for streaming the latest deep dive.
Of course.
Yeah.
But it means we're dealing with potential radio interference on a scale we've never seen before.
Okay, that makes sense. And that's what this new research paper is digging into.
You got it. Specifically, something they're calling Unintended Electromagnetic Radiation, or UEMR, coming from those second-generation Starlink satellites.
Hold on. Unintended. So it's like not even the signals those satellites are supposed to be sending.
You nailed it. The paper describes it as a bit like, a leaky faucet. Imagine the mainstream of water is the intended radio signal. Well, this UEMR is all the water spraying out from cracks in the pipe. It's radiation escaping from the satellite's electronics, not from the antennas themselves.
Oh, wow. I get it. Okay, so leaky satellites. What did the researchers actually find?
Well, they used this massive network of radio telescopes called LOFAR, and get this, they observed 141 Starlink satellites. And the results, let's just say they found that the newer Starlink satellites are way leakier than the older models.
Oh, no, really? How much worse are we talking?
Up to 32 times stronger, in fact.
32 times. Seriously. You know how those first-generation Starlinks caused a stir because they were so bright in the sky?
Right.
It's like, imagine something 30 times brighter. But this time, we're talking about radio waves.
Yeah.
Yikes.
Yeah, it's not good. And here's the other thing. These newer satellites are actually in lower orbits.
So even closer to Earth than the older ones.
Yep. And that's where it gets really problematic.
Okay, I'm officially worried now. But why exactly is it such a big deal that these satellites are leaking radio waves? What kind of impact does that actually have on, our ability to learn about the universe?
Think of it this way. Imagine you're an astronomer, right? And you're trying to eavesdrop on a whisper, but from across a crowded room.
Okay, tough, but I'm with you.
Now someone comes in and sets off a car alarm right next to you.
Ouch. Yeah, that whisper is gone.
Exactly. That's kind of what this UEMR is doing to radio telescopes. Those telescopes are designed to pick up the faintest cosmic signals and all this extra noise from the satellites. Well, it's drowning out the very things astronomers are trying to hear.
So, like trying to have a conversation next to a jackhammer. No way you're going to hear anything over that racket.
Precisely. And we're not even talking about just one jackhammer here. It's more like hundreds of them all going off at once.
Okay, that's just cruel. So is there anything that can be done? I mean, can't astronomers just, filter out this unintended noise?
Well, that's what the researchers were hoping to figure out. They actually dug deeper into the UEMR itself to try and pinpoint where it's coming from within these satellites.
Oh, so like opening up the hood of the car to see what's causing all that noise.
Exactly. And they found some really intriguing clues, especially in the data from LOFAR's low-frequency observations. We're talking about radio waves with really, really long wavelengths. And get this, the UEMR from these Starlink satellites, it's not just random noise. It actually has a distinct structure.
A structure, what do you mean?
Like a shape. Sort of. They're seeing a pattern in the data, a series of spikes, all lined up at specific frequencies. Imagine, like, a comb with teeth spaced out at regular intervals.
Wait a minute, a comb? How do you get a comb in space?
It's just an analogy, but it helps to visualize what's going on. Those comb teeth, they represent spikes of energy at specific frequencies. And here's the really interesting part. The spacing of those comb teeth, it's different for the regular Starlink V2 minis compared to the V2 mini DTCs, the ones designed for direct-to-cell service.
Wait, hold on. So you're saying that the type of service the satellite is providing, it changes the fingerprint of its radio noise?
That's exactly what it looks like. And that suggests that different parts of those two versions of the satellite might be responsible for the UAMR.
So maybe it's the specific component or a design flaw.
Could be. Now, the researchers couldn't pinpoint the exact source with the data they had.
Okay, so the case of the leaky satellite is still unsolved.
For now. But this comb-like signature they found, it gives the engineers at SpaceX a big clue to work with. Like, they know what to look for now.
It's like a cosmic game of Clue, but instead of a candlestick in the library, it's a rogue circuit board in low Earth orbit.
Love that analogy.
But speaking of clues, this is where I think we run into another problem. Regulations? Or, well, maybe the lack thereof.
Yeah, you're hitting on a crucial point there. While this discovery is exciting and gives engineers a place to start, the paper does highlight a big gap. There aren't any hard and fast rules right now about how much of this unintended radiation satellites are allowed to emit.
It's like everyone's throwing a party in space, but there's no noise ordinance.
Pretty much. It's a bit of a regulatory free-for-all up there, and that's a problem.
A big one. So we have astronomers trying to play a cosmic game of whisper down the lane in what's basically a mosh pit.
With leaky satellites, no less.
Exactly. What happens next? Can SpaceX even fix these satellites once they're already up there, or are they stuck being the noisy neighbors?
Yeah.
And then what about all the other companies launching constellations? Is anyone even thinking about this UAMR problem?
Oh, great questions. And they lead us to, I think, the bigger picture here and what could be a real turning point in how we approach space exploration as a whole.
Okay, so we've got this cosmic game of Clue going on, but it sounds like the stakes are way higher than just a board game here.
It's not an exaggeration to say we're potentially talking about losing a huge chunk of our ability to study the universe. Radio astronomy is on the line here.
Really, it's that serious.
Think about it. What if we build the world's most powerful telescope, right?
Ooh.
The kind that could detect these incredibly faint signals from the very, very early universe.
Right, yeah.
And then, because of all this interference from these mega constellations, those observations are just drowned out, useless.
So all that amazing technology wasted.
Exactly. And that's not even the worst case scenario. This isn't just an inconvenience. We're talking about fundamentally limiting what we can learn about the cosmos forever.
So, I don't know, you finally invent these super-powered glasses, right? The kind that let you see a million new colors nobody's ever seen before.
Okay, I like where you're going with this.
But then you realize you're stuck in a room with, like, the lights on full blast. So you still can't see those new colors because there's just too much interference.
That is a fantastic analogy, and it perfectly captures the urgency of what these researchers are trying to convey, because this isn't just about the satellites we have up there right now. We're talking about thousands, tens of thousands more being launched in the coming years. This UEMR problem, it could explode before we even know what hit us.
Okay, yeah, that sounds actually pretty terrifying. But I have to ask, what can we, and I mean, you know, regular folks who don't exactly have SpaceX on speed dial, what can we do about this?
Honestly, I think it starts with awareness. Just understanding that space, especially low Earth orbit, is becoming more and more crowded, and that has very real consequences. And not just for astronomy, either. Well, let's take space debris tracking, for example. We depend on ground-based radar and telescopes to keep tabs on all that junk flying around up there.
To, like, prevent collisions and stuff?
Exactly, but also to protect active satellites. But if those systems are blinded by this wall of interference from mega constellations, well, things could get pretty messy up there. Fast.
Oh, wow. I didn't even think about that.
And then you have to consider the potential impact of all this unintended radiation on other satellites. We're talking about a very complex web of interactions here, and we're only just beginning to understand how it all works.
So it's not just about, like, saving the pretty pictures.
Not at all. It's about the long-term sustainability of space itself.
Okay, wow. That's a lot bigger than I initially thought.
Right, and that's why this research is so crucial, because it's not just pointing out a problem, it's giving us the data we need to actually start looking for solutions.
So what, like SpaceX needs to go back to the drawing board?
Maybe. Or maybe we need to push for stricter international regulations about how much UAMR these satellites are allowed to emit. Or maybe we need to rethink how and where we build radio telescopes from now on. Who knows? The important thing is that we start having these conversations now.
It's like realizing your favorite campsite is about to get super popular, right?
Okay, I see where you're going with this.
You either need to, like, agree on some ground rules with everyone else who wants to use the space, or it's time to find a new spot for your campfire stories.
I love it.
And in this case, those campfire stories are about, well, the birth of the universe.
Yeah.
So no pressure, right?
Right, no pressure at all.
Well, on that note, I think we've given everyone a lot to think about today. To our listeners, I hope this deep dive has not only showcased just how incredible and awe-inspiring the cosmos is, but also how very real the challenges we face in studying it are.
We can't take our access to the stars for granted, that's for sure.
Absolutely. And maybe, just maybe, this has sparked an idea, a question, even just a conversation about how we can work together to make sure that the stars remain within our reach, both literally and scientifically. Until next time, keep looking up.